Hello dear students, welcome back to Learn Physics. In today's topic, we are continuing with the laws of motion chapter. Last class we discussed about the resolution of force, and in today's topic we are going to discuss about moment of force. What is meant by moment of force? Here in this case, here we are going to discuss what is meant by moment of force. Moment of force is given as torque. Moment of force means that is equal to torque. Torque we can find out by multiplying one force and perpendicular distance of the force from the axis of rotation. Suppose an object is here, a rigid body is here. According to this particular axis, it is rotating. If it is rotating in that manner, how we will find out the torque acting on the system? Then if this is the force which I am applying on the object, then perpendicular distance from the axis of rotation. Force and perpendicular distance from the axis of rotation will give you torque. Torque is represented by the letter tau. Tau is the representation of torque. So, torque is the product of one force and perpendicular distance from the axis of rotation. See, torque will be acting in the clockwise direction or anti-clockwise direction depending on the direction of applied force. See, we can use the screw rule for finding out the torque, or we can use the A cross B. It is R cross F actually. It is torque will be represented, torque is a vector quantity, so it will be representing as the cross product. Since it's a cross product, it's a vector product. R cross F is R F sine theta into vector n. Vector n will be the unit vector which is perpendicular to both R and F. In that manner also we can consider. Usually when we are considering the this torque acting on the system, anti-clockwise direction we will consider it as positive and clockwise direction we will consider it as negative. Okay, so this is how the sign convention which we are using actually, and it is not compulsory that we need to use the direction in such a way only. It is your wish. Okay, we can represent in any way. So here we are going to find out the moment of force acting on the system. For that, I am considering a rod which is AB, kept like this. AB is the rod kept over here, and on the rod it is applying a force 2F here, which is at a distance A from the point capital A. Okay, this distance is A, and another force F is acting downward direction, and this distance also given as A. And from F to B, the direction is the distance is 2A. So the different forces acting on the rod AB is given like that. And this rod here, A is pivoted at one point. Okay, so here this is pivoted, so it will be rotating. We need to find out the anti-clockwise moments. Anti-clockwise moment of each force about the pivot. About this point, what is the anti-clockwise moments? So here we can find out with respect to A. We are going to find out the what are the torque acting on the system with respect to A, because it is pivoted over here. When I am applying a force at this point, what will happen? It will start rotating in this direction, right? That is in the anti-clockwise direction. If I am applying a force in this direction, it will be moving in the clockwise direction. And here at B, another force is acting as, see, this is the force which is acting, which is 3F. This is the force which is acting at the point B, which makes an angle 30 degree. Now we are going to find out the anti-clockwise moment of each force with respect to A. A is pivoted. So what are the forces which is acting on this? See, forces are 2F at A, 2F is acting, F is acting, 3F is acting. Because of 3F, a torque will be acting at the point A. Because of F, a torque will be acting at the point A. Because of 2F also, another torque will be acting at the point A. Here we are going to find out this value of torque. So 2F is at a distance, 2F into A. Okay, and this here F is acting, the perpendicular distance is 2A. So here we can represent into 2A, and 3F is at a distance 4A. But here this 3F is not perpendicular to A, right? 3F is at a distance 4A. So when we are considering that distance, see, through the point AB, this 3F, I can divide it into components. So thus 3F will be acting, 3F cos 30 will be acting here, because near to 30 degree it will be cos. 3F cos 30, and this will be 3F sin 30. So one of force into perpendicular distance. So here, which is the force? 3F sin 30 will be the force acting on it. Okay, perpendicular. And the distance is 4A. So instead of 3F, here you need to consider 3F sin 30, because that is the perpendicular force which is acting. The force which is acting perpendicular to that. See, if it is acting in the same direction, 3F cos 30 is acting along the direction, along the length. Through that distance only it is acting. So why it is we are not getting any force, any torque because of that? Because we know tau equals R cross F. R of sin theta. Sin 0 is 0, because the angle between 3F cos theta and 4A will be equal to 0. Right? So we won't be getting any torque because of that force. So here 3F sin 30 is acting like this, and the perpendicular distance is 4A. So these are the different forces which are getting over here. And then here, because of this 2FA, in which direction it is acting? It is anti-clockwise direction. Here we require anti-clockwise moments only, right? So anti-clockwise moments will be, so because of 2F, it is moving in the anti-clockwise direction. So it has 2FA. And F into 2A, it is acting downward direction. So if it is considering as an anti-clockwise moment, here we need to consider minus 2FA. And 3F sin 30, that also acting in the upward direction. So it is positive only. Therefore, 3FA sin 30 is 1 by 2. Right? So this is here we will be getting it as 3F. F value is not given over here, so it will be sin 31 by 2. The total force will be 2FA minus 2FA and plus 3FA into 1 by 2 into 4A. 3F into 4A into 1 by 2. See, here 1 4 is there. So here we will be getting 6FA. 2FA, so 2FA will get cancelled. Final answer will be 6FA will be the anti-clockwise moment which is acting on this at the point A. So here the point A is pivoted at here, and with respect to this force, with respect to this point, we are considering the torque acting on the system. Okay, here perpendicular torques, perpendicular forces, if it is acting, no need to consider. There's think more and all. But if it is parallel, means a torque is not applicable over there. Then if it is perpendicular, we need to consider only the perpendicular components. Okay, clear children? So this is about the torque, how we will be finding out the direction of torque and all. Okay, next we are going to study about the coplanar forces. What is meant by coplanar forces which is in equilibrium? So what is, first we will say what is meant by equilibrium of forces. Equilibrium of forces means all the force acting on the system will be equal to 0, and torque acting on the system also will be equal to 0. If we are considering coplanar forces means forces which is acting on the same plane. if I am considering xy plane, and force along the x-axis will be equal to 0, force along the y-axis will be equal to 0, the torque which is acting in any axis, that will be equal to 0 if it is obeying the equilibrium condition. If the coplanar forces are under equilibrium, then the respective, if it is in yz plane, then sigma fy and fz equal to 0. So if depending on the plane, we will be considering the equilibrium. Okay, so here coplanar force means we know at equilibrium the total force equal to 0, total torque acting on the system as 0. So if it is in coplanar forces, then the net force acting on the system along each axis will be equal to 0. Okay, yes. So this is about the coplanar forces which is acting on the system. Okay, so next we are going to consider another one question here. Excuse me, let me take this one. For that, first I'll remove this, and here considering this, a rod AB rests at the end A on rough horizontal ground and the end B against a smooth vertical wall. The rod is uniform and of weight W. If the rod is in equilibrium in the position shown in figure, I'll draw that. Find frictional force at A, normal reaction at A, and we need to find out the normal reaction at B. So here, question, I'll read it once more. A rod AB rests at the end A on a rough horizontal ground and the end B against a smooth vertical wall. So here we need to draw the rod which is kept like this. One end is fixed at the point A on the ground and the end B against a smooth wall. The rod is uniform and of weight W. So weight will be acting exactly downwards W. If the rod is in equilibrium in the position, see, so this position is equilibrium, so the net force acting on it will be equal to 0. Find the frictional force at A. So friction is acting in the opposite direction. I'll represent it as frictional force here. This is the frictional force acting on it. Now next, what are the other forces? See, since it is over here, a normal reactional force will be acting perpendicular to the point B as well as perpendicular to the force A. Those are the normal reaction which is acting at A and normal reaction at B. F is the reactional force which is, frictional force which is acting over there. Here we need to find out the frictional force at A, normal reaction at A and normal reaction at B. Okay, first we are going to find out the frictional force. Frictional force is acting in this direction. To oppose that force, the frictional force is acting at A, which is acting in the left side, through the left side, towards the left side. So any forces which is acting towards left side or right side? Yes, this right side acting NB. So usually from here we will be considering this right side as positive and left side as negative. So here also I can consider NB minus FA, that is equal to 0. So here I am getting FA equals NB. Frictional force acting at A will be equal to NB. So this is for the first one. Then moving to the second part, normal reaction at A. So that is balanced with the weight which is acting, right? So here upward direction I am taking it as positive, Na minus W equals 0. So we are getting it as Na equals W. Now we are moving to the third one, normal reaction at B. So here we need to find out the normal reaction at B. So how can we find out the normal reactional force NB? For finding that, see here I am considering the if the rod is in equilibrium, it is given. So we considered to rho x, that is fx we considered, and fy also we consider. Next we can consider about the what is that, torque acting on the system is equal to 0. For considering the torque acting on the system is equal to 0, net torque, because at the point A, at the point B, and for W, what is the torque acting on the system? The total torque acting on the system we need to find out. So for A, how we will be finding out the total torque acting on the system? And here in this question it is given this angle is equal to 30 degree. That also given in the question. So tell me at the point what will be the, because of this point A, what is the torque acting on the system? Torque acting on the system as force into, that is Na is the force which is acting on it, and what will be the perpendicular distance. For that, here I'll take, see, Na is acting upward direction. Perpendicular distance means this distance I need to know, but I don't have that distance with me. Instead of that, I have this whole length. This whole length is given as 2L. 2L is the whole length of the rod. So 2L is making an angle 30 degree. This 2L makes an angle 30 degree. So what will be this value? It will be 2L cos 30. Okay, so force into Na into 2L cos 30. Okay, clear? So next is because of the point B. So it is clockwise or anti-clockwise moment. It is acting in the upward direction. So it is anti-clockwise moment. It is positive. Next I am considering for NB. NB, when it is applying like that, in which direction it will be rotating? It will be rotating in the clockwise direction. So because of B, it is getting a negative value for torque, that is minus NB. And what is the perpendicular distance? Perpendicular, this is the whole thing is 2L, and this perpendicular distance for NB. Perpendicular means we need to consider the vertical height. What is that? 2L sine 30. Okay, so Na 2L cos 30 minus NB 2L sine 30. Next is because of weight. What is the force acting, what is the torque acting due to weight? Whether it is clockwise or anti-clockwise, it is acting downward direction, right? Since it is acting downward direction, the torque will be acting, this rotation will be going like this. So it is clockwise, so we can consider negative sign. Force into, force is W. What is the perpendicular distance here? This is L. So if perpendicular to this will be here, that is horizontal direction, we need to consider L cos 30. That is equal to 0. Since it is under equilibrium position, we can consider that all these forces will be equal to 0. Now we got the equation, we can substitute it as Na into 2L cos 30 is root 3 by 2 minus NB into 2L sin 30 is 1 by 2 minus WL cos 30 is 1 by 2. Sorry, root 3 by 2 equal to 0. Okay, here Na 2L root 3 by 2, NB 2L by 2. So here if I am solving this, Na into L root 3 minus NB into L minus WL into root 3 by 2, that is equal to 0. Okay, we can substitute the value of Na as W. So W into L root 3 minus NB into L minus W into L root 3 by 2 equals 0. Okay, so here NB we can substitute it as FA also. So NB I am representing it as FA. Okay, so here substituting these values, we will be getting the value of FA. We can find out one value of FA from here. So here WL root 3 is common, 1 minus 1 by 2 minus FAL equals 0. So the rest of the calculation we can do it downward direct. See here, WL root 3, 1 minus half. So it is WL root 3 by 2 minus FA into L, that is equal to 0. So L and L will get cancelled. W root 3 by 2 equals FA. So we are getting the FA, frictional force, as root 3 by 2 into W. That is frictional force which is acting at the point A. That was the first question, right? First one was frictional force acting at the point A. So next one, NA, we already got the W as equal to, see here, Na equals W. Normal reaction at A we already got. NB equals FA. FA now we got it as root 3 by 2. So here FA we are getting it as root 3 W by 2. And second one is normal reaction at A, which one already got it as W. Third one, normal reaction at the point B, which is equal to root 3 by 2 into W. Okay, so these are the reactional forces. For that, we used all the three, that is in an equilibrium condition. If the rod is at equilibrium condition, total force acting on all the axes will be equal to 0, and the torque acting on the system also will be equal to 0. Clear, children? So this is how we will be solving. So I hope this video all of you understood this one, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.